We're looking at homework from section 5.3. This is question number 16. In a survey of women in a certain country, ages 20 to 29, the mean height was 63.5 inches with a standard deviation of 2.79 inches. Answer the following questions about the specified normal distribution. A. What height represents the 95th percentile? B. What height represents the first quartile? So we're going to start with part A. The 95th percentile, that's P95, and P95 means there's an area of 0.95 to the left of the z-score we're looking for. Since our table is given in 4 decimal place accuracy, we'll look for 0.9500 in the body of the table. Because 0.9500 is larger than 0.5, we need the positive side of the standard normal distribution table. So we cannot find 0.9500 in the table. However, there are 2 values that are close to it, 9495 and 9505. As a matter of fact, 0.9500 is exactly halfway between these two. And we've seen in the past that when we're exactly halfway between 2 table values, we use the z-score that's exactly halfway between the 2 z-scores. So the 2 z-scores that are here are 1.64 and 1.65. The z-score that's halfway between these is 1.645. So that's our z-score. But understand, this question doesn't ask for a z-score. This question asks for a height. And so that means we need to use the x-value formula that we find in our notes. The x-value formula is that x is equal to mu plus z times sigma. We have mu, z, and sigma, so we can figure out the value of x. Mu is given to us as 63.5 inches. Sigma is given to us as 2.79, and we just found the z was 1.645. So if we insert those values into the proper positions, we find that x equals 63.5 plus 1.645 times 2.79. Multiplying that out, we get 63.5 plus 4.58955. Added together gives us 68.08955. Rounded to 2 decimal place gives us a height of 68.09 inches. And that's your answer to part A. In part B, we're looking for the first quartile. Now the first quartile is equal to the 25th percentile. So P25 means that an area of 0.25 lies to the left of our z-score. Because the table has 4 decimal place accuracy, we'll look for 0.2500 on the table. Because 0.2500 is less than 0.5, we need the negative side of the standard normal distribution table. We look for the 0.2500, but it's not on the table. So there are 2 values that it's close to, but the closest value that's on the table is the 0.2514. And we said if it's not exactly halfway between 2 values, we use the value that it's closest to. So the z-score that corresponds to 0.2514 is negative 0.67. But again, we're not looking for a z-score here, we're looking for the height. So that means we're going to look to our x-value formula. In this case, x is going to equal mu plus z times sigma. Mu is 63.5 inches, sigma is 2.79, and we just found a z-score of negative 0.67. When we multiply the z and the sigma together, we get 63.5 minus 1.8693. We do our subtraction, and we find that this is equal to 61.6307 to give us a height of 61.63 inches. That represents the 25th percentile, which is the first quartile. So that's your answer to part B, and those are your answers.